guys, welcome to the first of two lessons on greatest common factors. So you probably saw this coming with us talking about polynomials in general, but we are going to go over factoring. So first off, I do want to say, well, welcome to factoring. We're going to be here for about 2 weeks, and hopefully by the end of those 2 weeks, you will feel a lot more comfortable with this than you have in the past. So this phrase gets used a lot in math, so people always tend to forget what is factoring. The basic definition of factoring is to break down a number into numbers that can be multiplied together to get the original number. And that sounds like a mouthful, so let me show you an example too, where 6 can be broken down as 2 times 3. And when we factor with polynomials, it tends to get a little more complicated. So we're going to take it a little bit slow right now, okay? We're going to first talk about something called greatest common factors. A greatest common factor is what is the greatest or the biggest factor that can go into 2 or more terms. And some of you can immediately tell what is the biggest number that goes into 1824. But let's say you're someone who struggles with this, okay? Here's my advice. If you don't know how to immediately just see what goes into 1824, break the numbers down. 18 can be written as 2 times 9, which is 2 times 3 times 3. And 24 can be 2 times 12, and I can keep breaking this down until we have 2 times 2 times 2 times 3. You will notice that after I completely factor this out, where 2 times 3 times 3 is as small as this could be, and 2 times 2 times 2 times 3 is the smallest 24 could be, that they both have a 2 and a 3 in common. 2 times 3 is 6. 6 is the biggest, it's the greatest common factor that goes into 18 and 24. Let me guys show you a little bit more complicated, right? What if we had 2 terms with a bunch of variables? Here's my advice. Focus on each part separately. What I mean by that is, let's focus on just the numbers first. 20 is 2 times 2 times 5, right? Good. And 16, if I was going to break it down, 4 times 4, which becomes 2 times 2 times 2 times 2. So now we have just the numbers broken up. But what about the x's? Well, x to the 4 is just x times x times x times x, right? And x to the 3 is just x times x times x. So if I wanted to look at the similarities, I noticed that both of them have at least 3 x's, right? And then with the y's, where the first one has a single y and the other one has 3 y's, I noticed I was going to highlight things. They at most have at 1 y, right? Because the other one, the second one, has 3 y's. The first one has a single y, so at most I could take out a single y for both. So look at this, guys. They both have 2 times 2, right? They both have 3 x's. They both have 2 y's. Let's put that together slowly. 2 times 2 is 4. X times x times x is x to the 3. And then we have a single y. And this would be the greatest common factor of these 2 terms. Now, if you look at the aim, though, guys, our goal is to figure out the greatest common factor of all terms of a polynomial. So let's actually do that. So here is a big polynomial. And what we're going to do, guys, is we're going to bring back an old friend. And we're going to take the 3 terms that are right here and put this into a box. See this, guys? We're going to use the box method to find the greatest common factor. And what you do is after you take every single term and you put it into this box, remember what I said, we're going to focus on just small parts of it? Notice that these are numbers and x's. Let's focus on just the numbers first. What number goes into 7, 21, and 14? You could break this down into 7, 7 times 3, 7 times 2, but you'll notice that all of them have a 7 in it. And because this is a negative, I'm going to say that all of them have negative 7. So ask yourself this. Negative 7 times what is negative 7? Oh, that's 1. Okay, negative 7 times what is negative 21? Oh, that's 3. And if you're confused on this, guys, if you can't think immediately what the number is going to be, try this. What's 14 divided by negative 7? Negative 2. So if you can't just think about, okay, negative 7 times what is negative 7, you could have just done negative 7 divided by negative 7 to get the top number, okay? Now that we have all these numbers here, we're done with that. Let's look at the x's. This is x to the 3, this is x squared, and this is x. What is the most amount of x's I could take out of each one without going over the amount for each term? Well, notice how this one is the smallest amount of x's. So at most, I can only take out a single x from each one. So x at 3, how many x's can I take from there? 1, so that's going to leave me with 2 x's. If I have 2 x's, I take away 1, that's going to leave me with 1 x. And up, there's nothing I can take out of there, right? So now, what we're going to do is take our answers, and I'm just going to put the negative 7x. This is our greatest common factor. That's as most we could take out. It's on the outside right here. And everything that is left over, x squared, 3x minus 2, it gets put in parentheses. And what's really neat about this is if I took negative 7x and multiplied every single term, I would get what we originally started with. But our goal was to figure out, okay, what's the biggest number? What's the most amount of x's I could just take out and put to the side of this parentheses and have the remainder on the inside. And that's how you find the greatest common factor of a polynomial, guys. I'll give you a few practice problems. But remember, there's going to be a second video, right? Otherwise, you have a good day. Bye.